Question 8, Part A. A drug is used to control a medical condition. It is known that the quantity Q of drug remaining in the body after T hours satisfies an equation of the form Q equals Q0 times e to the power of negative kt, where Q0 and K are constants. The initial dose is 6 milligrams, and after 15 hours the amount remaining in the body is half the initial dose. Part 1. Find the values of Q0 and K. The initial dose is 6 milligrams. In other words, when T equals 0, Q is equal to 6. So substituting T equals 0 into the equation here and Q equals 6 in the equation here, we get 6 is equal to Q0 times e to the power of negative k times 0, and negative k times 0 is 0. So 6 is equal to Q0 times e to the power of 0. And noting that e to the power of 0 is equal to 1, so 6 is equal to Q0 times 1, hence Q0 is equal to 6. The next step is to find the value of the growth constant K. Now we know that after 15 hours, the amount of medicine in the body is half of the initial dose of 6 milligrams. In other words, when T equals 15, Q is equal to 3. So substituting 15 for T here and 3 for Q here, noting that we have the value for Q0, which is 6, we can solve for K the equation 3 equals 6 times e to the power of negative 15k. Dividing both sides of the equation by 6, we get 3 over 6 is equal to e to the power of negative 15k. Taking the natural logarithm of both sides, we get ln of 1 over 2 is equal to negative 15k. Dividing both sides by negative 15 to make k the subject, we get negative 1 over 15 times ln of 1 over 2 is equal to k. Hence k is equal to 1 over 15 times ln of 2, since negative ln of 1 over 2 is equal to ln of 2. Therefore, Q0 is equal to 6 and k is equal to 1 over 15 times ln of 2. Part 2. When will 1/8 of the initial dose remain? Solve for T the equation 1 over 8 times 6, which represents 1/8 of the initial dose, is equal to 6 times e to the power of negative kt, where k is equal to 1 over 15 times ln of 2, which we found in part 1. Dividing both sides of the equation by 6, we get 1 over 8 is equal to e to the power of negative kt. Taking the natural logarithm of both sides, we get ln of 1 over 8 is equal to negative kt. Dividing both sides of the equation by negative 1, and noting that negative ln of 1 over 8 is equal to ln of 8, we get ln of 8 is equal to kt. To make t the subject, we divide both sides of the equation by k, so t is equal to ln of 8 divided by k. And that equals ln of 8 divided by 1 over 15 times ln of 2 in brackets, which evaluates to 45. Therefore, 1/8 of the initial dose remains after 45 hours.